Hello everyone. So let us solve the next type of problems in hydrograph. That is, the ordinates of a 4 hours unit hydrograph are given in the table below, and derive the ordinates of a 12 hours unit hydrograph by the method of superposition. So there are two methods to solve the unit hydrograph. Now, one is by S-curve method and the other is by method of superposition. So we have already studied the problem on S-curve method. The same problem is now uh, done by method of superposition. Okay, you can see here time first. In the first column there is time. Second column, it is 4-hour unit hydrograph. It is in meter cube per second. Okay, so it is from 0. Okay, time is from 0 to 24. The same problem we have solved by S-curve method in the previous video if you have checked. Okay, the same will be solved by method of superposition. Okay, so here they have given 4-hour unit hydrograph. Now, out of from this 4-hour unit hydrograph, they have asked you to solve it by find out the 12-hour unit hydrograph. So the multiple of 4 is 12. So what we can do here is what we'll do is the first 4-hour lag time. So the first 4-hour lag time here is 4 hours here. So from 4 to 4 is 8 hours, and from 8 plus 4 is again 12 hours. Okay, that's how it is. Now we already know 4-hour unit hydrograph, so we have mentioned here, we have written here. Okay, next, the third column, you can check this out. So it is 4-hour unit hydrograph lag time. Okay, so there is a lag, so the lag is by 4 hours. Now because it is by 4 hours, so what I'll do here, the same values, okay, 4-hour unit hydrograph values, the same values we'll be writing it from the 4th hour, because there is already a 4-hour lag. So the 4-hour lag here is first two will be blank. So from the 4th hour, so 4th hour, again all the values should be written. The same 0, 25, 100, 60, all the values up to the last 1.5 and 0 you should write. Okay, because it is the lag, 4 hours you should show the lag. Then for the same unit hydrograph, again we'll lag it by 8 hours. So by 8 hours if we lag it, so that means from the 8th hour we'll write this. So this would be so we'll keep it blank. There's 1, 2, 3, 4. Okay, so from the 8th hour we'll again write the same set of values. So see here, first up to 6 hour it is blank. Then from 8th hour the same set of values, there's 0, 25, 100, 160 and all that one by one. Okay, again there is a lag up to the last point, that is 1.5 and 0. Okay, all right, so we got the lag by first 4 hours, we got the lag, and next 8 hours we got the lag. But ultimately what we want is we want the 12 hours unit hydrograph. So to find the 12 hours unit hydrograph is, you can see here the next, that is we have to add in the fifth column, we need to add 2, 3 and 4. Okay, 2, 3 and 4. This is like the first 4 hours. Then if you lag this would be 8 hours. Again, if you lag this by 8 hours, this will be 12 hours. Okay, so total, so the lag here is 4 hours and 8 hours. So we have this up to 8 hours, but ultimately we want this from 12 hour from this point. Okay, so we lag it 2 times. All right, then we'll add this now, 2, 3, 4. 2, 3, 4. Okay, 25, 100, 160 plus 25, 185, 190 plus 100 plus 0, 290. So next 170 plus 160 plus 25, this. Okay, we'll go on writing this up to the last point. All right, okay, so now ultimately if you want to measure the ordinates, now this is the ordinate of a 12 hours altogether. But if you want to find the unit hydrograph, so the ordinates of the 12-hour unit hydrograph is given by this column, that is fifth column, divided by n. Now n is nothing but, you can see here, it is the lag from first 0 to 4 is uh, first lag, 0 to then 4 to 8 is the second lag, and 8 to 12 is the third lag. Okay, so now this is one method, like n is equal to 3. That is one method you can find. Or previously also we have found out the method wherein what you can do is we are finding a 12-hour unit hydrograph. So 12 divided by 4, time duration here is 4. So 12 hours divided by 4 will give us 3. So 4 3s are 12. So n is 3. Okay, So now what you have to do is this unit 5 column divided by 3. So 0 divided by 3 is 0. Then 25 divided by 3, 8.33. 100 divided by 3, 185 divided by 3, 290 divided by 3, and so on. You should go on calculating this. So this final column will give us a ordinates of a 12-hour unit hydrograph. So this method is checked by uh, method of superposition. The same problem, okay, the same problem we have solved by S curve method. Okay, we can always cross check the values here. Okay, you can see here S curve method, save 0, 25, 100, same set of values, but the method is different. So 0, 8.33, 33.33, 61, the same values is here. 0, 8, 33.33, 61.67, same it is. Only the method is different. In both the method, if you solve by both the method, you'll get the same answer, either by S curve or by method of superposition. If they specifically mention any method, then you have to solve by that particular method itself. Okay, in the same lines, let us solve the next problem. That is, the ordinates of a storm hydrograph of a river due to 6 hours isolated storm are given below. Derive the direct runoff hydrograph and obtain the ordinates of 6-hour unit hydrograph for the basin. The area of the catchment is 423 kilometers square. Okay. So again in the first column they have given you time. Next column is discharge in meter cube per second. Okay, so again, time is from 0 to 6, 0, 6, and so on up to 90. And at the same time, there is a discharge. So from the discharge, you have to calculate first from the discharge. So if they are not giving you directly any hydrographs, so they have only given you discharge. So from discharge, you have to first find the ordinates of a direct runoff. From the direct runoff, only then you can calculate the ordinates of the 6-hour unit hydrograph. Okay, so first discharge is in meter cube per second, so they've given you discharge here. Okay, from 10 to the last point 90, it is 12.5. Okay, next is out of this discharge you have to separate the base flow, because base flow is nothing but it is the water which flows beneath the subsurface of the soil. Okay, that you have to always deduct from the discharge. Okay, so this would be so first let us take the first and last values. The first discharge value is 10 and the last discharge value is 12.5. Okay, so we need to calculate the base flow. To calculate the base flow, okay, first the first term here is 10. Okay, okay, so you have there are two methods to calculate this. So first is this method which I'll tell you. So first flow is flow value, discharge value is 10 plus outward. Okay, this is the last discharge minus first discharge, the final discharge by the initial discharge. So final discharge is 12.5 here at 90 minutes and divided by initial discharge, that is 10. So 12.5 minus 10 divided by total minutes. So total minutes here is 90 into respective duration. So into respective duration, these are all 6-hour duration. That is 6. Okay, so it is 12.5 minus 10 divided by 90 into 6. So only this value, okay, only this value will give us 0.16. The value here is 0.16. Okay, now this value should be added to all of these. So first value 10 should remain 10 only. Then for this 10 value, we'll go on adding the number, that is the base flow. You have to go on adding the base flow, that is 10 plus 10.16. Then plus again for this 10.16, again go on adding 0 again 10.16 plus 0.16, 10.33 plus 0.16, 10.5 plus 0.16, and so on. Go on adding. Okay, we have done this type of problem in the previous video. If you have checked with the previous problem, the same concept is done. From the discharge, we are going to deduct the base separation value, base separation flow. Okay, which is also called as base flow. Okay, once you deduct this base flow, so total discharge, okay, from the discharge would be both. It would have runoff also and it would have base flow also. So now what you have to do is we have to deduct the runoff from this. So from the total discharge, we have to deduct the base flow. So the total from discharge, so basically it is base flow plus direct runoff will give us discharge, right? So from now, from the discharge, you have to deduct the base flow to get the direct runoff hydrograph. Okay, so you can see here this column 4 would be 2 minus 3, that is 10 minus 10. 10 minus 10, 0. 32 minus 10, this answer. 87.5 minus 10, 115.5 minus 10, 102 minus 10, and go on up to the last value. You should calculate this. Okay, once you get this ordinates of a direct runoff, so you have to add this. Sum of the ordinates of the direct runoff is 592.45. Calculate this. Similarly, next, now calculate the ordinates of a 6-hour unit hydrograph. Okay, now see here, to calculate, this is the direct hydrograph, direct runoff hydrograph, but we are interested in 6 hours unit hydrograph. Now to convert this into 6 unit hydrograph, it is the column 4 divided by excess rainfall. So first we'll calculate how to find out this excess rainfall. Okay, so for excess rainfall, the volume of the direct runoff, first we'll calculate volume. So if you have to calculate excess rainfall, it is nothing but volume divided by area. Area we already know, so we need to just calculate the volume. So now volume of the direct runoff hydrograph is given by sum of all the ordinates of the direct rainfall or runoff hydrograph into time interval. Okay, so now see here we already calculated the ordinates of the direct runoff hydrograph. So this is the ordinates of a direct runoff hydrograph. So it is 592.45 into time. So time interval here is 6 hours. So 6 hours should be converted into minutes and then into seconds. So that's why it is 6 into 60. So from hours it is get converted to minutes. Then from 60 into 60. So from minutes to seconds. So it is 6 into 60 into 60. Okay. So this is the volume of direct runoff hydrograph. Now again you can see here the unit of this is meter cube per second. So meter cube per second into second. So second will cancel. We are left with only meter cube. So it is 592.45 into 6 into 60 into 60. So this is the volume of the direct runoff. So this is the volume of the direct runoff. Now area of the basin, we already know it is given in the problem. So the area of the basin is 423 kilometer square. So convert this kilometer square into meter square. So 423 into 10 to the power 6. So kilometer into meter, that is 10 to the power 3. But because this is square, you have to square this. So 3 into 2 is 6. Okay. So now both are in meters. So excess rainfall is given by volume divided by area. So volume we have already written here divided by area. 10 to the power 6, 10 to the power 6 cancel. So excess rainfall is given by it will be in meter. Again you can see here this is in meter cube, this is in meter square. So meter square cancel. In the numerator there we have left with only meter. So it is excess rainfall is equal to 0.03 meter. Again multiply with 100, then it is 3 centimeter. Ultimately we want it in centimeter. So excess rainfall you calculate here. So it is 3 centimeter. So finally the ordinates of a 6-hour unit hydrograph is given by column 4 divided by excess rainfall, that is 3 divided by 3. Excess rainfall we already calculated. So it is 21.84 divided by 3, 7.28, 77.17 divided by 3, 105 divided by 3, then 91.34 divided by 3, and so on. Go on calculating. Okay, so write the summation of the 6-hour unit hydrograph is given by the total value here, that is 197.6. Okay. So in this, see, whenever they give you time and discharge, then always from the discharge deduct the base flow, then find the ordinates, and then find the 6 hours unit hydrograph. Okay, this is direct runoff hydrograph. This is the unit hydrograph. So unit hydrograph is nothing but you will get it only when you divide it with the excess rainfall. Again, excess rainfall is nothing but volume into area. Okay. From, if they give you discharge, time versus discharge, then you have to calculate all of these. Okay, first you have to calculate base flow, ordinates of direct runoff, then ordinates of 6-hour unit hydrograph. In the previous problems, if you have checked out, they used to give us directly the unit hydrograph. So they used to give from 4-hour derive 6-hour, or from 4-hour divide 8-hour or 12-hour. Okay, that is easy. Okay, all right. That's all for today. Thank you.